Okay, so now we're going to look at solving second degree trigonomic equations. So to start with, we're going to look at how to solve this algebraically. When you see a second degree trigonomic equation like this, you're going to want to move all your terms to the same side. So I generally like to make my leading coefficient positive, so I'm going to move the sine x to the other side, to the left, so it becomes positive sine x, as well as that positive 1 to the left, so it becomes negative 1. So now this looks exactly like a quadratic equation that you have factored so many times by now, except for there's a sine x instead of a variable. So what we can do is let's substitute a variable in for sine x so it looks a little more familiar. So we're going to say let a equal, that's supposed to be an equal sign, sine x. And we're going to rewrite this equation with that a value. And all we're doing is substituting the a in for the sine x. Now you guys have seen this a million times before. So from here, I will just factor. You can factor using any method. I will use the decomposition method. 2 times negative 1 is negative 2. Two numbers that multiply to give me negative 2 and add to give me positive 1 are positive 2a and negative 1a. Now from here I'll split this in half and factor each half. So on the left half side I can take out a 2a. On the right side I can take out a negative 1. And then bring those coefficients in front together. So I have 2a minus 1 times a plus 1 equals 0. Now I can just solve for each of my factors. So I know a equals 1/2 as well as a equals negative 1. Now that I've solved for a, I'm going to substitute sine x back in for a. And I'm running out of room here, so I'm going to write back over here. Let's actually write, sine x equals 1/2 as well as sine x equals negative 1. Now, of course, we've learned how to solve from here. We've learned using the castrol. We've also learned using the unit circle. So whenever I see a familiar ratio, I'm always going to check the unit circle first just to save myself a whole lot of time. And I'm just going to draw the Cartesian plane here as well. So let's pull out our unit circle and look and see where sine x equals 1/2. So sine x, of course, is the second coordinate in our ordered pair. Sine x equals 1/2 at positive pi over 6, as well as 5 pi over 6. So I know my two angles there are pi over 6, and I'm just going to draw them really quick. Pi over 6 and 5 pi over 6. So I have pi over 6 and 5 pi over 6. Okay, now I'm looking to see where does sine x equal negative 1. Okay, and again, let's check our unit circle first. So sine x equals negative 1 at 3 pi over 2. Right here, 3 pi over 2. So those are my three angles, and again, are those angles in that domain? Yes, they are. Always check the domain. So those would be my three solutions. Now the next step is it wants me to state the general solution. So we've done this quite a few times. General solution is the same idea as when you were stating coterminal angles, expressions for coterminal angles. So general solution just represents all the solutions that would give us sine x 1/2. So we write a coterminal angle expression. So I take pi over 6, because that's my principal angle, plus 2 pi n, that represents one rotation, where n is any integer. And then I'll do the same for 5 pi over 6, as well as 3 pi over 2. Great, and those are my three general solutions. Yay! Okay, so now this is the exact same question, except for we're quickly going to show you how you can do this graphically. We just did algebraically. I forgot to cross this out and write graphically. So whenever you have two sides of an equation, we talked about this in logarithms and exponentials as well, you can always graph. Well, the same holds true with trigonomic graphs. So I'm going to go to my graphing calculator. On the left side, I will type in, or y1, I'll type the left side of the equation. So 2 sine x. You are going to put a bracket around that before you put your squared, because we want the sine function to be squared, not the x. Okay, and then the right side, 1 minus sine x. Okay, from here, the trick is your window. I'm actually going to graph in in degree mode, because I know talking to some of you, that's definitely a lot easier. So let's try graphing in degree mode. Okay, and then I gotta make sure I'm in degree. I'm in radian right now. Okay, now I'll just press graph. There's my intersection point. So you can see it intersects 3 times, which is good because I have 3 answers. Okay, and then I can just find each one of those intersection points. So here's my first one, left side, right side, and I get 30 degrees, which if you look on your unit circle, or if you convert, is the same as pi over 6. And you could also graph in radians. You'll just have to make sure those decimal values match your angles as the exact value as well. Okay, so that's great. You can double check any question you do by using your graphing calculator. All right, let's just look at a couple more examples here. So we're going to start with 4 sine squared a minus 1. Again, you may be able to factor this just by looking at it, and that's fine. If you're looking at it though and you're not sure how to factor it, you can always rewrite it and then factor. I'm actually going to substitute a variable in again. So I'm gonna pick a different letter instead of a though, because a is already used in the expression. And again, you don't necessarily have to substitute a variable. So I have 4b squared minus 1 equals 0. That is a difference of squares. So then I end up with 2b plus 1, 2b minus 1 equals 0. Solve for b, so then b equals negative 1/2, b equals positive 1/2. Substitute sign in, a in. There. And again, hopefully this should be familiar. These ratios are once again on your unit circle. So if you jump to your unit circle, sine is equal to positive 1/2 at pi over 6, as well as 5 pi over 6. Sine is equal to negative 1/2 at 7 pi over 6, as well as 11 pi over 6. So I have 4 different solutions this time. So I have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, and just for time's sake, I'm going to skip this one here. Definitely you could try it though if you want some extra practice. The solution is on Moodle with the notes. Okay, let's try this one here. So we have cosecant squared x minus 3 cosecant x. So don't be tricked just because that's a reciprocal function. You can do the exact same thing. So let's go ahead and substitute a in for cosecant x. All right, so we have a squared minus a minus 28. Two numbers that multiply to give me negative 28 and add to give me negative 1. Or negative 3. Whoa, where did my 3 go? Are negative 7 and positive 4. So then when I solve, a equals 7 and a equals negative 4. Okay, so now I'll substitute cosecant x back in. So cosecant x equals 7, cosecant x equals -4. All right, so now you're not going to stop there, you'll take the reciprocal. Cosecant x is of course the reciprocal of sine. So I'm going to write 1 over sine. And then -1/4. Okay, so now these angles, actually those aren't on our unit circle, so we'll have to use the castrol here. So I'm going to write the castrol up. So I always check the unit circle first. If the ratio is not on there, then I'll use the castrol, just because the unit circle is a lot less work. All right, so let's start with our first ratio. We know sine is positive in quadrants 1 and 2. So to use the castrol, we'll go to our calculator. And we're going to go second. And again, you should be in degree, right? Because the angle of the domain is in degree. Second function sine 1 over 7. And I end up with 8 degrees. I'm just going to round to the nearest whole here. So I have an angle of 8 degrees. And then I will use reference angles, which is also a reference angle of 8 degrees, to find the second angle. So if it has a reference angle of 8 degrees and it's in quadrant 2, that second angle should be 172 degrees. So those are my first two solutions. And now I'll do the same with the -1/4. Okay, so I know sine is negative in quadrants 3 and 4, which actually, when you go back to the question, the domain is from 0 to 180, right? Those are the only angles we should be finding. So these two angles are outside of that domain, so that means we actually don't need to find the solutions there. So our only solutions for this question is 8 degrees and 172 degrees. All right, this is another one you can go ahead and try by yourself. Same idea, you can check online. Let's look at this diploma question before we leave today. So it says the value of x that satisfies the equation and for the interval. All right, so I'm going to start by once again bringing everything to the same side of the equation. So I'm going to add that sine x over to move it over. Then I will factor the sine x out, which gives me 2 sine x plus 1. And then I'll solve for each factor. So my first factor is sine x equals 0. My second factor is sine x equals -1/2. These are both on the unit circle, which is wonderful. So again, if we jump to our unit circle, we know sine x equals 0 at both 0, pi, and 2 pi. Okay, this interval though, the domain, is from -pi to +pi. And make sure you note, this is where the diploma always tricks kids. The bracket, the square bracket, means includes, so it includes -pi. The round bracket means does not include, so not including, right? And that just deals with interval notation there. Okay, so I know I have my 0 and my -pi, right? Because that negative angle would be -pi, but I will not include the positive pi because it's outside of the domain. So I have these two solutions. And now if I look to see where sine x equals -1/2, okay, it should be at 7 pi over 6 and 11 pi over 6. So over here, 11 pi over 6 is the same as -pi over 6, right? Because we want the negative angle. And I know that this negative angle would be -5 pi over 6. Great. So those are my 4 solutions, which gives me an answer of D. Again, this is another perfect example of something I could also graph, and I could set my domain to the interval that is in the question. So graphing is just such a great tool when you're working with solving equations. Okay, so that's it for today. Try some examples, even just trying some of those questions in the notes that we skipped through. That would be a great idea, and trying a few questions in the workbook is also super helpful. Let me know if you need any help.